Hi, everyone. Thank you all for being here. We have the pleasure of having with us today Sebastien Gerard, Antonio Bucchiarone, and Ansgar Radermacher with a tutorial on PapyGame. Sebastien Gerard is Research Director at CEA, List, where he is leading the research flagship program INCA on collaborative augmented digital engineering. He's also leading the Eclipse project Papyrus and a member of the Eclipse board of directors for CEA List. Antonio Bucchiarone is currently a senior researcher at the Motivational Digital Systems, MODIS, research unit of the Bruno Kessler Foundation in Trento, Italy. His research activities focus principally on many aspects of the software engineering for adaptive socio-technical systems. And finally, Ansgar Radermacher is working on model-driven engineering tools for embedded and autonomous systems, in particular in the context of Papyrus. So please go ahead. The floor is yours.
Thank you, Noon, for this nice introduction. So our tutorial will be about gamification initiative we start, I guess, almost 2 years ago with Antonio, Ansgar, and other peoples. And the idea of this initiative was to try to make all the tools we were building around model-based system engineering, model-based software engineering, more efficient. Because one of the most black point, I would say, that is often raised with regard model-based engineering is the complexity of the tool. So the idea was to look at the gamification direction and to try to use this paradigm in order to make easier model-based system engineering. So today our presentation is split. Our tutorial is split in 3 parts. First part is about an introduction of what is MBSE and what is Papyrus and how to start using Papyrus. I will deal with this part. Next, Antonio will talk about the gamification program we start, and more specifically on PapyGame. And finally, Ansgar will talk about one specific game which is dedicated to software design. So first, before discussing more in detail model-based system engineering and BSE, I would like to show you a short video outlining the paradigm of MBSE. Okay, so now we can try to define or have two definitions which can be useful to go further. First of all, to be sure we agree on what we are talking about, let's give these two definitions. First, we define a model as a computer-based formal or semi-formal representation of a system and of its context. And secondly, we define model-based system engineering, MBSE in short, as being representative of approaches to system development in which computer-based models play a fundamental role. Model-based system engineering approaches contrast with document-based approaches. For the latter, the knowledge representation play an essential role instead of the knowledge itself. Expectation from MBEC can be categorized into three domains, three categories. First, it shall increase productivity through hyper-automation practices. Secondly, it should have an impact on the quality of developments by fostering and keeping consistent and coherent all the design artifacts produced and exchanged by stakeholders of a design process. And finally, it will reduce the effort related to complexity management while increasing the designer's confidence that they have made the right choices throughout the system design lifecycle. So, the key benefits of models or model-based software engineering are following. Working with higher level of abstraction closer to problem domain. Potentials for stakeholders oriented system representation of complex systems. So having a dedicated language for dedicated issues. Automatically traceable links between related system elements. Traceability is a key point for complexity management. Ability to automate some design task, as for example, some code generation task, as we will show that later with Ansgar. Ability to automate complex system analysis like schedulability analysis or cost analysis. All these characteristics can directly improve quality, productivity, and complexity management. Model-based system engineering is definitively a problem of knowledge engineering, and it relies on two main well-known paradigms, abstraction and automation. And sometimes we also say hyper-automations. Abstraction is all about knowledge description, including questions such as which languages are to be used, what are the best concepts for abstracting my knowledge area, what are the best representation or signs to communicate and exchange my idea with others. Automation is about computer-aided services. Automation, why should we automate or rely on computer-aided assistance? First, it can enable you to foster model analysis by enabling integration of complementary external tools. Like, for example, formal mathematical analysis, simulation, and testing tools could be integrated in your modeling workbench. You can also use automation to provide a support for automatic refinement-based process, which will provide you more better robustness or processes, no more cut and paste error, which are very often in system engineering. And you will be more efficient because when you practice some agile process, you need to repeat very often some process. So having them automated will be very efficient. You can track, verify, and propagate change in your model due to the traceability information. And you can generate consistent artifact because no more cut and paste error. And you can monitor, drive, and synchronize your development process using these automation tools. So in summary, model-based engineering is a method for designing and implementing complex systems in which computer-based models play a fundamental role. It is based on two fundamental paradigms, abstraction, high-level abstraction, and high support of computer automation. And you should benefit in 3 categories of quality: increased productivity, increased product quality, and greater ability to manage growing complexity. In addition to that, it's very important, or we think it's very important to rely on 2 aspects when you are going to develop a model-based system approach. First is to use standard, because standard is very useful to reduce and manage the risk. Better interoperability, industry-wide norms, availability of experienced engineers, availability of education facilities, enabling vendor independence. And second, we do think also that open source is a key feature, because you can improve, you can sustain core technology, which is very important in our domain. You can develop and benefit an ecosystem around core technology, and you can also reinforce standardization effort by having reference implementation. In that context, there is Papyrus. Papyrus is the Eclipse project for modeling, for UML and SysML modeling, and you can use it directly by downloading it on the Eclipse website. So a bit of history about Papyrus. So Papyrus started around 2007, so more than 10 years now. It was it was already an Eclipse IDE. It was written in Java by hand. It was using some specific technology like JF, EMF, and so on. In 2009, there was a major revision of Papyrus, which was the result of merging with 2 other projects, one called Mosquit from Spain, and one what called Topcase. It was a project led by Airbus around open source tools. At that time, we create an Eclipse project, so Papyrus become officially an Eclipse project. And we move from handwritten Java to generation from GMF. And since 2009, we produce 4 versions per year following the official release train of Eclipse. And all these versions are still available on the server of Eclipse. Papyrus is a family of products, including the 2 main products, which are Papyrus UML and Papyrus SysML, which are respectively dedicated to UML and SysML modeling. In addition, you also have Papyrus Toolsmiths, which is there to help you model and design your modeling tools specific to your domain or business using the UML profile mechanism. And remember that SysML itself is designed as a UML profile. And later in this presentation, Ansgar will talk you about Papyrus software engineering, which is, as its name suggests, support for software engineering, including code generation services such as the current scope. The current scope of PapyGame Initiative is Papyrus UML and Papyrus Software Engineering, but still we plan to extend and welcome any volunteers to help us do so. On this slide, you can see snapshots of different domain-specific tools implemented with the Papyrus Toolsmiths. For example, for smart grid system design on the top left, or for robotics on the top right of the slide, or even for smart form system as shown on the bottom right of the slide. Now let's see how to start using Papyrus. So first of all, you need to install Papyrus. So you can go to the website of Papyrus. It's www.eclipse.org/papyrus, and go to the download section. And there you get all the possible installation of Papyrus. So you can install Papyrus either using what they call RCP, what Eclipse call RCP, for rich client platform. So you can download the version you want. So we have for Mac, Linux on Windows and so on. So you just have to download and you unzip it and it's done. If you have already installed or Eclipse, as for example using the download page of Eclipse, so you can install you can download the installer of Eclipse. In that case, you have to choose the Eclipse modeling tools configuration. So you start the install, you launch it. When it's launched, you have to create your workspace, and then you will be able to add a Papyrus extension. So update seat are the Eclipse mechanism, is the Eclipse mechanism for adding new software to an existing Eclipse configuration or updating already installed plugins. The seat location, that is to say the web URL or the archive file for the update site, is the only required information you need to go. On the Papyrus web page, go to the download section and you will find this section with Eclipse Papyrus update sites. And so you have three categories of update sites. So you have the latest release update site, which is the most, which is I would say the one we advise or we recommend for beginners or for standard users. Then we have the latest release, which is in fact a nightly build. So if you are a technology enthusiast or early adopter or experienced user, this version is for you. Papyrus nightly build is produced every night from whatever has been released into the master branch of the GitHub repositories. So you have all the new fix, all the new features which are progressively implemented inside Papyrus. And then if you need an older version for some legacy reason, you can download whatever past version you want using this information. So when you have launched your Eclipse in your workspace, you have to go to Help menu, install new software. Then you have to add a new extension. Here you will have to either choose if it is a local or an archive file for the update site. You set a name, you specify the path to the update site, and then you click, and you will have that. You will have installation of Papyrus ready. So when you have Papyrus, if you install the rich client platform of Papyrus, you will have to execute the papyrus.exe file. You will have a dedicated splash screen, and then, as we showed previously, it's you have to specify the workspace where you want to work, and you will be ready to use Papyrus.
Sebastien, apologies for the interruption.
Yes.
We have a remark here from Padita Stevens saying that even full screen on a biggish monitor doesn't make the small text on these screenshots legible for me and perhaps others. Could the speaker be aware and read things out?
Okay.
Okay, thank you.
I will try to do my best, sorry.
Thank you.
So tell me if it is still wrong. Anyway, the slide will be available later, so we can show later if we don't see it now. I see. Okay, sorry. So one of the main concepts to know about when you're starting with Eclipse is the concept of Eclipse Workspace, which contains projects, and the projects can contain other projects, files, or folder. But you need to, in order to start, you need to create a project in order to be able to create file. And for Papyrus, we have specific project for Papyrus and specific project for Papyrus model. And you can use this wizard, which file new Papyrus project or file new Papyrus model in order to create your first model. When you start to create a model using a new Papyrus model, you will have to choose which language you want to use. And in this example, we have UML, we have SysML 1.7, and we have a Profile, which is the first editors of Papyrus Toolsmith to create your abstract syntax of your DSL using the UML profile mechanism. And then you get this kind of UI. We have first the Project Explorer, which is the kind of equivalent to file system to go over your models in your workspace. Then you have the Model Explorer, which is a kind of tree-based editor for your model. Then you have the model editors themselves, which can be here, it's a graphical model editor, but it could be a tabular editor. You have a main toolbar where you can have services for the open diagrams. You have the property editor, which gives you the ability to see and to change the meta properties of each element you select in your element, as for example, the name of an element or the visibility of an element, according to the definition of the meta element in the UML model. And you have an outline view that provides a bird's eye view of the current editor, of the editor you have selected in the model frame. You have this concept of perspective, so you have a Papyrus perspective that you can use to reset or to come back if you manage to change the frames of your windows. If we see the model editor section, so you have this palette. The palette contains tools, and you are using the tools to create the graphical element for the representation you want to make. As for example, here is a state machine editor, so you have all the elements to create state machine. And you have the general annotation elements that we used to use when making UML model. This is the editor tab. Here you have to care about that the star means that the diagram, the model has not been saved, so you should save it in order not to lose your last modification. You have view tabs. Each tab holds for one open diagram. Here we see that there are 4 open diagram or 4 open views, because this view here is a table and not a diagram. And you have a specific tab, which is a kind of a welcome page for Papyrus that give you an outline of what are the existing view in your model. So when you have created a diagram, you can first create a model element, which are nodes, so a class, a package, a model are nodes. So you have several means to do that. The first procedure is to use the editor itself, the diagram editor. So here, sorry. So if you want to make it with the diagram editor, in the palette, you have to make the choice of the element. You click on it, and you click on the background of the diagram, and you will create the node. Here it is a package. If you want to rename it, you just have to press the F2 key, and you can put a new name and hit enter to validate your new name. Or you can also make a double click, on the tool in the palette, and it will create automatically for each double click a new element in the diagram. And if you want to use, you can also create model element in the Model Explorer using the what we call the new child menu. So you can create nodes with SysML or relationship, and so on. So you just have to select the element. and then it will create an element in the Model Explorer. If you want to show this element into a diagram, you will just have to drag and drop the element from the Model Explorer onto the diagram you want to show, where you want to show your element. Again, if you want to rename, you just have to press the key F2. You have several means to make nice diagram. So you can align left, right, bottom as it is usual. You can also manage the distribution of the element using some nice distribution strategy. You have to select the element and then you have to choose which distribution you want, if it is horizontal or vertical, and so on. And then when you have nodes, you may want to create edge, such as links, dependencies, association. For that, you just have to select the relationship you want to create. And then you click on the source and you click on the target. Or you can also select the two elements you want to select. So the first one will be the source and the second one will be the target. And then you double click on the tool you want to use. Here we create a refined relationship between requirement 1 and requirement 3 by doing that. And again, you can also change the name of a link or an edge using again the F2 key. You have several means to manage the routing of the edge. So you can make rectangular style routing. You can make oblique style routing, as for example. You can also have tree style routing for generalization, as for example, as shown here. And you can have also several appearance facility to make this kind of edge, depending on the style you want to use when you are making your diagram. You can also refactor. You can also, make some rerouting of edge. So, as for example, if it is like that, make hit key control plus up key, and you will have directly the nodes which is aligned with the other node. And again, you have two solutions. Either the upper node is moved in that case, or the upper nodes is not moved. You have on control plus shift plus up key. Sorry. And you can also use the bar tool instead of the short keys if you want. You have possibility to put hyperlink. So there are different kind of hyperlink. You can make an hyperlink toward a view, toward a specific object, toward a document in the local file system, or toward a website. So it's up to you to choose. So you have the control plus L short key, or you can navigate, modify hyperlink, and then you create the hyperlink you want. And doing that, when you have an hyperlink, if you double click on the element, it follows the direction pointed by the hyperlink automatically. So you can improve navigability in your diagram, in your model. An important point to know, which is fundamental to know when we are making some kind of modeling, it's the difference between the model and the representation. So in the tool, you have two actions which are important to understand, which is a delete selected element or delete from diagram. So delete selected element will delete the model element from the knowledge base. So it will disappear from the representations, but it will also disappear from the database. If you only want to hide it from one diagram or another, you have to use the delete from diagram option. In that case, the representation of the element is deleted, but not the element itself. This is very important to understand. So now you know everything to download, to install, and to start using Papyrus. And I will pass the mic to Antonio in order I can talk about the gamification of Papyrus and PapyGame.
So thanks a lot, Seb. So let's try to share my slides. Do you see my slides, right?
Yes, I see.
Okay, good. So, and in this part of this tutorial, I will introduce you what we did in terms of gamification to improve in some way the usability of such model-based software engineering tools, and but also from the other perspective, so how to engage students or trainers to learn more about model-driven engineering and especially some characteristic of a specific tool. So we have implemented PapyGame. So starting from my background, so now I'm a researcher at Fondazione Bruno Kessler in Trento, where I'm responsible of research, a specific research area on gamification, but in particular how to use gameful systems and mechanics to educate people and to train people in companies, okay, to use a specific tool or specific methodologies. So the goal of this work was related to the motivation that you see in the slides. So we want to augment the classical model-based system engineering tools with self-training facilities. So documents are fine, tutorials are fine, but when the teacher wants to teach a specific topic, for example, class diagrams or sequence diagrams and so on, in some way, these augmentation, so the additional aspect of gamification in such tools can help a lot the teacher to teach a specific concept and also to understand what should be the learning curve of the students, or the employees in a company. And the other aspect is, sorry.
Yeah. If you don't mind me interrupting, we have a question. Would it be a good time?
Yeah. Why not?
So we have a question from Avi Sheikh asking, are there any known real significant, preferably industrial, uses of Papyrus, or is it just used for demonstration purposes? He personally tried it several times and it was not stable enough to work with or even for teaching purposes.
Yes, I can answer to that question.
Yeah, of course.
First, maybe I don't know if you know the ANSYS company. ANSYS company is making a tool like it's such as Dassault system or Siemens, as for example. And so one of the tool of ANSYS company is called Architect System, and Architect System is based on Papyrus. Ericsson is using Papyrus. There are some other use case story on the website of Papyrus. There is a company working in the space domain, which is Spacebell, which is using Papyrus. Currently, we are working with SNCF, which is a railway French company. We are developing a big tool for them based on Papyrus for dealing with rail networks. There is two other smaller company like Sherpa Engineering and Silforces who are releasing their tool with Papyrus, and so this is the example I have in mind. And we are using it every day to do our job at CEA, and we are going to deploy it at the CA level. So I don't know what he's trying to do with it, but on our side, maybe we can exchange later with him if you want. We managed to use it with student also, and I guess Antonio did it also because he did some experience in his context with some other colleague in University of Lille and also in Sweden, where they have done some experience. I don't know if he's talking about that, but
a
using
little bit,
PapyGame.
yes.
So I let you continue, Antonio.
No,
Thank you.
thanks a lot. Thanks a lot, Seb.
Yeah, I'm also using it in teaching. Yeah.
Okay.
Sorry.
No problem. So continuing this discussion, in general, the introduction of this gameful system is a general concept that we can apply in education, of course, as I said, but also in training in a company, in the sense that we can use the same techniques to train people to use a specific feature of a tool and to engage them in learning more and training more during their job with the gamification concept. To make them engaged during the usage of the tool, okay? But also to understand phenomena, understand, for example, from the producer perspective, in this case, from the Papyrus perspective, we should be to update or to change the feature and to make it more usable for the end user, okay? So this can be used for the both purposes. Of course, in the experience that we did this work with students with a goal to reduce the modeling learning curve, and as you can see in the slide, to encourage the user to persist with the usage of this tool, despite the effort required to learn any tool. That the initial point is kind of a difficulty. And this is why we want to have a self-training facilities in general for model-based system engineering tools. Okay, so gamification, as I said, is one of my research field. Gamification means when we want to use game design elements in non-game context. So when we say serious games, it's something that we want to apply for a serious purpose. In this case, the serious purpose is to learn and train on model-based software engineering or modeling in general. Okay. So we, in some way, experience a lot in gamification. We have developed different mobile apps and web application for end users with the concept of with the goal to change behavior. Okay, for example, in mobility, on health domains, on sport domains, for example. And here we push the gamification in modeling. So we did the same work as in another domains. In general, we reuse the main elements and main concepts used in gamification context. So as you can see in the slide, you can see that you can start from basic elements of a game. So when we need to gamify the system, we need to add the concept of action. So what is the action done by the user, that we want to monitor and assign a specific score, to the specific action. We want to define different type of points, so that could be experience points or other type of points that we attach to a specific action executed by the user. We want to have a way to define challenges. For example, we have the week for the UML class diagrams, or the week of multi-level modeling, for example. And we assign exercises and games specific for this kind of purpose. So we have badge collection. We want to collect in some way the behavior of users and assign a specific badges, like the expert of class diagrams, or the expert of state machines, or assign a specific level for the learning curve. If you are an expert or if you are a basic student, and so on and so forth. And of course, we want to create also the dynamic aspect of gamification. Also, for example, the competition between students or employees, for example.
Antonio,
sorry.
Apologies. We have a message from Surat Ajit saying, "I'm trying now, but PapyGame is not loading the URL. Could you check if the URL is the correct one?"
Yes, I will do at the end. Okay.
Okay, thank you.
So of course the website should work, but we will check later. Okay. So of course we have the mechanics that will use the basic elements to provide set dynamics that I said. We can have cooperation where we do, for example, collaborative modeling, and we can assign games or challenges to a specific team that collaborate for a specific modeling. We want to engage people, for example, one user that's engage another user to play and accumulate points if invite other students, for example. And we have competition when we have the leaderboard elements and the ranking mechanics that will help to create competition. So we want to have a prize for the first 3 students in the class, for example. No? So these are the basic elements. And what we did, we used these elements and these concepts that are common in gamification to gamify a software modeling environment. So in general, we can do this approach for any tool. We did this great experience with Papyrus. But our approach is targeting 3 different stakeholders. So first of all, we need a gamification expert. So it's the expert that design and develop the artifacts related to the gamification. For example, the game elements, mechanics, and dynamics that we saw in the previous slides. That is related to the learning goals. So what we want to achieve, what are the behavior that we want to implement in the specific experience. Of course, we need to have the modeling teaching expert. So the teacher, in this case, the tool vendor at the end could be also the expert, that want to push some aspect on the tool, and then the user, of course, that could be the students, the language expert, or software developer that use the gamified version of the tool to learn modeling, with the specific tool and enhance in some way the experience and expertise level while playing the game. These are the main aspect of what we mean about gamified software modeling environment. So what is our vision is described in these conceptual architectures. And as I said, this is related to, can be applied to any tool in modeling that we want to gamify. So in general, we have the software modeling tool that is the core part. So in some way, we need to have access to the source code of the modeling tool. We need to understand what are the actions that we can monitor of this software tool. And this is very important because we need to relate this tool to the gamification side. So this is the work that we do with Seb and with other colleagues. So we understood first what we can do with Papyrus, what are the modeling actions that we can monitor, and what are the data that we can log and memorize to understand the activities done by the user. Memorizing also aspects like the time spent to execute a certain modeling activities, how much times the user did a specific action in the modeling editor, the complexity of the model and all the aspects related to the model. For example, the name of the class, the attributes, the parameters, the methods in a class, the relationships between classes, the multiplicities, are all information that we logged in a JSON file, for example, while the student is modeling. And these are the information that we pass to the component that we call the model quality assessor. That is the component that in some way evaluate the correctness or the goodness of the model respect to the game, respect to the game model. So what we want to achieve, why the model is correct. It's not the correctness in terms of the structure of the model, but the teacher can express different constraints to evaluate the model. That could be, for example, the attempts that the user used to upload the last model, the correct model, or how much time the user spent. These are the constraints, how much classes the model includes. And these are the constraints that the game expert can define together with the teacher to define the game. So when we have the game actions, we can call the gamification engine. So this means
Antonio?
yes.
Sorry to interrupt you. May I pose you another question, please?
Okay.
We have a question from Juha-Pekka Tolvanen saying, trying to reduce the learning effort is welcome. However, is the reason why modeling with tools is considered difficult because many modeling tools are built on top of non-modeling tools? UX, features, support for collaboration, versioning, etc. are then built on the basis to manage strings, not models. Example, adding modeling capabilities to Visual Studio has been hard and been tried many times.
So I don't know if I catch the point, but of course, any tool has its own features, and it depends on which kind of learning aspect you want to push. And in this way, gamification can be used because with the teacher, you can decide what you want to monitor first. So what are the actions that you want to monitor? And of course, what are the data related to this action that you want to pass to the gamification engine? Because as I said here, in the gamification engine, you evaluate the model, no respect to the teacher constraints. Okay, for example, what we did is one constraint from the teacher was the class diagram must contain at least 4 classes for this exercise. Okay, but doesn't touch the name of the class or the attributes. No, but 4 classes are enough. At the end, is the teacher that will look at the final model if it is correct respect to the semantics of the scenario. But in this case, gamification will check other type of constraints. So we did an experience also with Visual Studio, for example, for coding, for gamification on coding, and it works. So it depends on the goal of the learning that you have. I hope that answered the question, but of course, I'm open to other discussions and comments on this.
Thank you. If there are any follow-up questions,
okay,
I'll make sure I'll interrupt you again.
No. You should do. You should do. So I love a lot to have open discussions. So.
Appreciate it. Thank you.
Okay. So, and the last point was, okay, there is a game dashboard that is the user interface that the players see with accumulate points and feedbacks during the game. And the gamification design framework, that is a framework that I developed in my research group to define and design the games on top of a modeling tool. Okay. So in general, the game dashboard, so the PapyGame is composed by 6 elements. Okay. The first is the game dashboard. So we extended the Papyrus environments with this specific user interface that you can see as a menu, as a view in Papyrus. So when you start the PapyGame plugin, you see this view, and you can start directly with your game. No, so I will show you a video where all these steps are executed, but I will describe the one by one technically now. So the player can see the game dashboard, can log in to this view with the username and password, and can access to the available games. And of course, the player can see the player status for how much points are accumulated, the nickname, how much players have been sponsored by this player. If the students has reached a prize, can claim the prize. Can fill a questionnaire, for example, during the game to accumulate more points, and can see the leaderboard. And at the same time, can see the levels reached. No, so this is a game done by a certain set of levels from level 1 to level 8, and these are the 8 exercises that the teacher define together with the game expert, and that we deploy in PapyGame now. So the second view is the software modeling view. So you use Papyrus, as you know. So you can model within the Papyrus view. You can, in this case, the game was about the UML class diagrams. So you can model the classes assigned exercise by exercise, and you can use the palette and all the stuff that Seb mentioned before. In a classical way using Papyrus. But while modeling, as I say, there is the backend that memorize all the activities done by the students, memorizing the needed information for the game. So the third element is GDF. GDF stands for Gamified Design Framework. So you can define a game using this framework. So you can see details on these published paper models. And this is the framework that we use to model the first example in PapyGame. So GDF is based on a lot of languages. I don't want to go in details on this, but if you read the paper, all the details are there. In general, GDF is composed by a set of languages, a set of domain-specific languages. This is done using JetBrains MPS. So we saw a very nice tutorial during these events. So we have a set of languages for the game definition, plus a set of languages for the game utilities to simulate the game, for example, or to adapt the game during the execution, because sometimes we could change the game rules during the execution if we discover, for example, that a lot of players are stacked in a specific point. We want to give feedback to the user. We can do this, or we can change the next exercise because we discovered that the learning curve is very high and they don't need an extra exercise, or we need an extra exercise if we didn't understand a specific concept during the game. So we can modify, also adapt the game at runtime. So, and the fourth component is about the gamification. This gamification engine is an open source tool that we developed in FBK. So this gamification engine now is used in different gamified applications, not only in education, but we use also in mobility and in another context where we have projects. This is an open source engine. You can download the use from our Git repository. It is based on rules, a rule engine. And these components take care of running games, take charge of updating, for example, the status of the players in terms of points, in terms of a badge reached, in terms of leaderboards, positions, and so on and so forth. So it's in some ways the core components that execute the game rules. Okay. So we have the game master that monitor the game execution and send the game result to the gamification engine. So this is the components that is in charge to evaluate the model and the data received by Papyrus, and understands information about the models done, not only syntactically, but also with other constraints that the teacher can define. And of course, notify the player the progress, so read the status from the gamification engine and send back to the player the status of the games in terms of points and position in the leaderboards. The model comparator is the last component. It is responsible to assess the correctness of the modeling actions or the complete diagrams. And we can do this in two ways, in real time. So, for example, any action of the model can trigger an evaluation request. This is done and this is sent back to the player with feedbacks. Or we can do it at the end of the exercise. So at the end of the exercise, when the player submits the exercise, the model is compared with the target model defined by the teacher plus extra constraints, and the result is evaluated and accumulated in the gamification engine. So let's see first a very short a video on how PapyGame works, and I will come back to you with the last part of my presentation. Okay. And let me know if you have problems on the video, but I hope not. So here the player can log in to the PapyGame with the view that you can see in Papyrus. As you can see, PapyGame is a view of Papyrus. So when you enter, you see the dashboard with the current game assigned to the user with the levels. The player can select the first level, and here, for example, we have the description of the project, of the main projects, and description of the specific level. So what the player must do. For example, in this case, the player should model a UML three UML classes: book, author, and publish company. And for each class, there are an indication from the teacher that the player should use the Java class naming convention, for example. No?
Antonio?
And plus we have the game rules, because this specific exercise is related to the specific type of game. In this case, we have the on your own game. So this means that you need to model your diagram, and when you have done, you need to press the specific button. So the player will read this description. When the player is ready, can progress, and we upload the specific modeling space. You know, so now using Papyrus, the player can model the class, the 3 classes requested by the exercise. You know,
Antonio, could I briefly interrupt you, please?
Yes.
We have a question from Stefan.
Yes.
Is model evaluation always through comparison to a master model, or are the forms of tests possible too?
No. So we did a first experiment, that is what I'm showing here, that we compare the source model with the target model described by the teacher. But of course, in the second experiment with the University of Bucchiarone in Sweden, we did another type of evaluation. So the teacher expressed the set of constraints as a JSON files, and we compared these JSON files in the gamification engine with the model done by the user. So collecting information about the class, how much classes, how much relationships. It's a more general evaluation, not very strict to the syntax of the model. So, but with the gamification engine, you can express a lot of rules in natural language that we transform in rules, and it's very open to the decision of the teacher. So we can do both. Okay.
Thank you.
You're welcome. So we can proceed with the modeling, and so the third class is defining by the player. And so when the player is done, he can test the model, pressing the button, and the gamification engine is calculating, comparing the results and evaluating. And here we have the gamification side, you know, so how much moves you did, how much errors, how much seconds, how much points in terms of experience, in terms of gold coins, you know, that we model in the game. Of course, all these elements are defined in the gamification model and are related to the specific exercise. So when you have done, you can resume to the dashboard. You can come back and you can see that you passed the first level, and you can progress on your exercises, or you can see the leaderboard. So you can check what is your position in the classroom, for example. So in our website, we publish the leaderboard, that you can see that with this exercise you reach this point and you have this position in your classroom, for example. So, and when you have done with this, you can come back to your game, and you can continue also in other sessions. So because each exercise is a standalone exercise. So in this second example, for example, we have another type of game. So that is the hangman, so another typology. So here you need to draw your diagram of what each error you do, you contribute to the construction of the famous hangman. No? So each piece of this man is composed by errors. So each error that you do, you increase the penalties in some way. No? And you have the description of your exercise that you modeling. Okay. So this is more or less what we can do with this version of PapyGame. Let's come back to the slides. Okay. So the other part that I want to briefly introduce is how the teacher can use PapyGame. Okay. So of course we have a lot of research to do in the site, but we started to understand what are the pieces that the teacher should specify with GDF, with the gamification design framework. In general, the teachers must specify in this specific case of PapyGame instance, the source model that is composed by diagrams. Each series of the game is composed by a set of levels that the player can reach, and these levels will contribute to specify the game. Of course, we have the level rules. So for each level, we express the game rules that are the constraints that must be verified for each exercise.
Antonio,
Yes.
another question.
Yes.
From Sebastien Moser. The
Yes.
comparison is always text-based, as in equals. If I use volume instead of book, then the engine will flag it as incorrect, right?
Yes, there is a syntax check on the names. You can do this, but you can also evaluate, for example, the name, the parameters of the methods, for example, the multiplicity of the relationships, for example, and the constraints are based on this. The JSON file that I was mentioning is a translation of the natural language requirements from the teacher. And this JSON file from the teacher perspective is compared with the JSON file extract by the running model, so by the model done by the player. So we have these two JSONs, and of course we need to express the constraints in terms of the name of the class, the methods, all the in some way the meta model of a class diagram in some way. Okay.
Thank you.
Mm-hmm. But in general, by experience, so we did the first attempt with a very strict comparison of the source model and the dark model, okay, in terms of strictly fixed should be the same, okay, to summarize. The second experience, we in some way relaxed these constraints and we did this through this JSON file comparison. Of course, it depends on the game. We can change the methodology, depends on the game. And this is doable because the gamification engine is a rule-based engine. So everything that you can express with rules and with data that you receive from Papyrus, you can do. Okay. Of course, as I said, the teacher can select the GISM and create the content, introducing the levels, representing the class diagrams, and of course we have the game part. So what are the game mechanics that we want to push to the player, the type of games, for example, the hangman and all your own that we define in this instance. In the other experience, we extend this implementation with the third type of game that is the flow, like the player should learn using the flow from the simplest exercise to the more complex in a specific context, like class diagrams. We started from a single class, we move to the complete class, relationships between classes until the very complete class diagrams, like a flow experience. Of course, we have the gamification engine to define the rules. So this is a snapshot of how the gamification engine is. So we can define, for example, the rules with a specific rules language, specifying the points that we want to modify upon a certain action that is called task completed, for example. And we can use GDF to express this. So we supported 3 types of games: Hangman, Flow, and On Your Own, as I said. And we had initial set of results. One is the best paper, best demo award at Models 2020. So that we really appreciate as a first outcome of this experience. Now we are doing real experiments with students. For teaching UML class diagrams, we did this with the Malmö University in Sweden, with dividing the class into a portion of groups, 23 groups that used Papyrus, 24 groups that used PapyGame, and now we are collecting their feedbacks and their results, to understand how gamification was useful or not for this type of experience. We are collecting very interesting results that we are we are planning to publish sooner and the Symposium journal. And we are planning, of course, to extend experiments with other universities, like University of Lille in France, and with the University of L'Aquila, with a different type of game, with targeting the multi-view consistency, multiple diagrams, not only class diagrams, but use cases, sequence diagrams, and component diagrams, with the goal to evaluate the consistency between these multiple view modeling. Okay, so in this case, the rule, the constraints will be very, very different respect to the game that we did. So here I would like to leave you with some references that are related to the gamification part. So what I did in the last 2 years on gamification. Some papers are related to more general stuff about modeling, and other are strictly related to gamification and how to use gamification in software engineering in general, but in specific in model-driven engineering. And one of these chapter you can find in this language, where we use MPS to define the gamification part of this tool. Okay, I did from my side. I'll leave the floor to the speaker for the last part of our tutorial. Thanks a lot.
Yeah, can you hear me? Can you see my screen?
Yes.
Yeah, in this last part of our tutorial, I like to talk about Papyrus Software Designer and the link with gaming. So if you're doing Papyrus Software Designer, you are producing specific models that are suitable for generating code. So what is Papyrus Software Designer? It's an extension of Papyrus that allows you to generate code and also to synchronize this code with your model to some extent. And you can, on the one hand, generate structural aspects of your model, so standard classes and their relationships. And you can also have some behavioral aspects in form of state machines. And well, what has partly already been said, the objective behind that is that we want to foster that design and implementations are aligned, and also that your model is productive. So it is not just a documentation, but it really captures your final system, and there's no divergence. There is also, well, there are two complementary ways to look at these execution of models. One way is to execute it directly. It's a kind of simulation engine or virtual machine that is able to execute your UML models, and that is based on the UML action language ALF, and another Papyrus extension that is called Mocha. And you are able to execute them directly. The specification have some visual feedback on the screens what the current state is. And the complementary way is to generate code, then compile this code and execute it to see how your model behaves. And that's the aspect I want to talk about today. It's semantically aligned with formal UML, so it's a subset of UML that has a precise semantics. And there's also this another OMG specification, precise semantics of state machines, that defines how the semantics for these state machines is supported. And of course, the code generation has to make sure that it is well aligned with that. If you want to try Papyrus Software Designer, you can download it from the links that is shown here. You can also put it into the chat afterwards. and you can install it in addition to an existing Papyrus. So here's some slides that show how software designer works. Well, we have on the one hand the code below, and then we have a model that is relatively close from the abstraction level to the code, in the sense that if I have a C++ class or a Java class, then I have directly the corresponding model class, and the operations are corresponding, the attributes are corresponding. So it is a bit more high level, but the semantic gap is relatively small. And we might have some annotations on these classes that guide us how to support the elements that are missing in UML to support certain programming language construct. But we also have a higher level model. So for instance, if we are looking at application components, so components with ports and possibilities to exchange messages via these ports, then we could have a higher level model, and we could have some specific interaction component libraries that tell us how implementation-wise data is exchanged between these application components. So without requiring that the user has to know all the implementation details, he can just specify, I like to use a certain interaction mechanisms on my connectors that I draw between these application components. And as said before, we can also have high-level application behaviors in form of state machines. And we then want to have a transformation that transforms this high-level model into an implementation model. Well, I have the information here. Well, I've largely already talked about this. You could have here a high-level application architecture with respect to deployment, in which you capture all your instances and the concrete configuration you want to have of your classes or components. And yeah, well then here with respect to the interaction library, we have done some work, for instance, that you can load specific libraries, and you can get communication mechanisms that are based, for instance, simply on socket communications or on OMG DDS or ROS2. I will have some more words about ROS2 later on. And then you have this model transformation that transform your high-level model into a model that is quite close to the application code that will finally be produced, in the sense that method bodies are partly already in the classes in form of bug behaviors tagged with these specific programming languages. And you have these annotations, for instance, that a certain parameter should be a pointer when you're generating C++. And then we have the code generation and reverse engineering mechanism for these languages. Well, I have to say Python is not yet publicly available. That's work we are currently doing. They have to have also the Python support, but the other three languages are available. So you can have a round trip and synchronized model and your code. Some information about code generation for Java. Well, it's basically 1.8 or Java 11, and we have a dedicated UML profile that supports these elements in Java, which have no direct equivalent in UML. For instance, if you want to have a method that is synchronized, you cannot do that, specify that with UML without using a specific profile. And there is also a model library that has the primitive types, and we have a model library that has the subset of the standard classes you're often using, mostly list classes, container classes. There's no big surprise when it comes to mapping of packages from UML to Java. So it's reflecting the file system hierarchy as Java requires. So we get the packages with this information. We have, if we have an opaque behavior on the model level, then we already have the code that is contained in this behavior in the generated class file. We support, of course, all the structural relationships, enumeration and primitive types. And there is a programming language independent support to handle templates, which is possible in UML with standard mechanism, but it's a bit more complex to use. So I won't go into detail. The same is, of course, also available for C++. We also have a dedicated profile there with the concepts such as pointers, type definitions, or friends that do not have a direct equivalent in UML, and we support a subset of the C++ standard library. With respect to state machine support, we have a pretty complete support of state machine generation aligned with the PSSM, or precise semantics of state machine semantics, and we do that via model-to-model transformation. Here's a short screen that shows you that on one hand you see here an operation in the diagram, and you see here a method on the left, and you have here in the property view the code of this method in form of an opaque behavior. And you can see that with Eclipse CDT, so the C++ development tools, you can here see the code equivalent of this class. You also see that, for instance, here we have an attribute that is volatile, and another that is, I think, const and volatile. And you see that it is here. I think this is this one, constant, volatile, and static. You see that it's here in the generated code, and it respects these two specific stereotypes to produce the C++ elements that we want to have. And before coming to gaming, which is, of course, the main topics of this talk, I'd like to talk about current work we are doing in the context of more specific code generation. So there is another extension that is called Papyrus for Robotics, in which case which will generate code for ROS2. ROS2 is a robot operating system. It's mainly a kind of middleware that is much used, widely used in robotics to support publish, subscribe, interaction between robotic components, some timers, and a quite rich library of existing data type definitions that are often used in robotics. And so from an assembly description like this one, where you have just two component instances, there's also some configuration behind that you don't see here in the image. And a component definition, for instance, with some periodic activity, we generate then complete build files, so that are CMake list, package XML, we generate launch scripts, and we generate the component code. So that is work that is built on Papyrus Software Designer, is internal technology. It's a bit hidden from the user. It's just using the robotics extension. But it's interesting to see that we can make use of these base mechanisms to build something a bit more complex. Okay, that's information I've already told you about. So what is interesting now with respect to gaming? Well, if you're doing code generation, you already have one element at least that is a bit similar to gaming, because you have this reward. If you are developing software, you want to see, will it run, will it compile? And so you have already this reward, but it's a bit steep learning curve, and it's not obvious how to model, for instance, some programming constructs. So if you get this presentation in form of a game, and you see, okay, and if I want to have a constructor, for instance, then I need to apply a certain stereotype on an operation. Then it helps you to get the feedback. Is my model a good model? Does it do what I want? So it's really an additional reward and for the user, and an additional motivation to learn how to use this. And these are examples, or the constructor was one, but there is a pointer variable in C++. So in the game description, we can embed some of the hints how to do this, and this helps then the user to write these models that have a code equivalent from which we can easily then generate code. And well, we have some work that is currently ongoing in this context. So it's not it's not already available right now that you can use PapyGame for code generation enabled models. The reason is that we have to this JSON information that we send to the server needs to be augmented a bit. So we have already added this. Mainly main task is, as you have seen before, stereotypes play an important role when you're writing or developing a model that can be used for code generation, and therefore we have to transmit also this stereotype identification in the serialized JSON data. We have done that, but we didn't have the time to finish the game-specific rules. And there's also more complete coverage of UML elements. So for instance, if I'm modeling a state machine, having transitions with actions and so on, then I also need to enrich these JSON data in order to have these validation rules. So this is work in progress, and as we have still quite a lot of time left, maybe it's useful if I show you just some concrete models here live on the Papyrus system. So this is a robotic system. If you're knowing ROS2, it's similar to one of the tutorial examples that in code form come with ROS2. And here, interesting thing is that you have a diagram based on Papyrus, but you have a pretty much reduced user interface. So that was a bit also a question we had before. So here's the user interface. The palette is showing information that is dedicated to the specific domain, and doesn't include all the elements you have in a standard composite structure diagram on which this system here is based on, that I'm describing here. there's also some information. Oh, this is the code that is generated, but there's also some information that can be seen here if I select now these dummy joint states component diagram. I can see here an activity, and if I select this activity, I see that there is a periodic activation. If I select the periodic timer, I see that there is a certain period length in milliseconds that is used to drive this timer. And yeah, something we have experienced as well, that sometimes a text representation is also could be more efficient for certain things. So we have here an equivalent text representation of this component. And of course, you can choose to run such a system. So I can, for instance, decide to launch here the code using Papyrus, and then to I have to zoom out to see that here we are now starting here a simulation panel for robotics, in which we are driving these visualization tasks. And this has, with the parameterization and the periodic loop and the communication of different JAWS nodes that are interacting. Okay, well, this is just an information what we are doing in Papyrus for robotics, and it would be interesting to guide the user to specify these systems with the gaming options. And something we have ongoing for very simple Java code is here. You see a Hello World example that is written in Java, and the task for user here that makes this interesting is to not only specify an operation in Java, but to say there must be some behavior behind. This behavior can be supplied in form of an opaque behavior with the language Java selected, and it will just do a system out printed on Hello World. And with Software Designer, we can have here a sub-menu. It allows us to generate code from this model, and we get then a simply a generated JDT project, and I can run it as a local project, local Java application, and then you can see the Hello World here. We have, well, this is really the starting example, but a bit more interesting one is if you want to do template bindings, then this is often a bit of a hassle to do that in UML. You can, well, here use a list class. So what we want here as a task is to have a test class having a list of string, also a collection of strings, and this list should correspond to the Java util list that many of you know. So what you, well, probably you can't read it, but what you have here is a subset of this Java util library, which is available as a registered model library. And then you can drag and drop this list element into your diagram, and you can create your own list of strings that is binding the template parameter e to string. And then you can type your attribute with this list. And this would be one way of doing it. And when we are evaluating this with, we will be evaluating this with the PapyGame engine. We will then check here that all the suitable data are available in the JSON and can be evaluated. And there is another way of doing it, which is a bit more direct. We can do this with a template binding. So I guess,
Ansgar,
yeah, there's a question probably, yeah?
I think we're sort of running slightly over the end of the session at this point.
Oh, okay. I thought we had more time. So yeah, that's more or less everything I wanted to say. So yeah, here it's just I wanted to say this is an alternative way of doing it. We can apply this template binding stereotype to an element and directly type our element with a list, and then say and the actual attribute of the stereotype. This is a list of strings. And yeah, I like to happy if there are any questions. Then I will be happy to answer these.